Hi dear students, this class I am going to discuss formation of a differential equation. How to form the differential equation for the given curve. That's what we are going to discuss in this particular question. You see the first question, y is equal to a into sin x plus b. What is the procedure we have to follow to form a differential equation? First of all, check in the given equation how many arbitrary constants are there. You can check in this particular example, y is equal to a into sin of x plus b. Here a comma b are arbitrary constants. That's why we have to check how many arbitrary constants are there in the given curve equation. So here we have two arbitrary constants. That's why we have to differentiate it two times. Two times we have to differentiate it, and then we have to eliminate the arbitrary constant. That is the way we are proceeding. So here first time differentiation, y1 is equals to a into sin x plus b differentiation cos of x plus b, right? Again differentiate this one, y1 differentiation is y2 is equals to a into cos x differentiation is minus sin of x plus b. Now what we can write this one as? So this we can write it as y2 is equals to minus y. So we can write y2 plus y is equals to 0. So for this family of curves, this is the differential equation. So observe how many arbitrary constants are there. Those many times we have to differentiate, and then in the final answer there is no involvement of arbitrary constant. This is the differential equation for this family of curves. Okay, just sometimes they will ask number of arbitrary constants. This solution we are calling it as a general solution for this differential equation. General solution for this differential equation. Sir, what is a general solution? The solution of this differential equation is said to be a general solution. The order of the differential equation 2 is the order for this differential equation. The order of the differential equation must be equal to the number of arbitrary constants in the solution. Number of arbitrary constants, how many are there in the given solution? That many, that is the order of the differential equation. Here number of arbitrary constants is equals to 2. Order of the differential equation is also 2. So this solution is called a general solution for the given differential equation. Sir, what is the another solution? Yes, we have another solution also, that is called a particular solution. By giving some particular values to the arbitrary constants, by giving some particular values to the arbitrary constant, the solution obtained is called a particular solution for the given differential equation. Suppose you see y is equal to sin x plus 2 and a is equal to 1, b is equals to 2 given, we got this solution. Yes, this is a solution for this differential equation. This solution is called a particular solution, and this solution is called a general solution. Number of arbitrary constants is equal to, in the general solution, the number of arbitrary constant is equal to order of the differential equation. The number of arbitrary constants in the general solution is equal to order of the differential equation. Now tell me, the number of arbitrary constant in the particular solution of a differential equation is 0. Because in a particular solution there is no involvement of arbitrary constants. For these arbitrary constants we are giving some particular values. That's why this solution is called a particular solution. Now tell me, what is the order of the differential equation for the family of these curves? How many arbitrary constants are there? 2 arbitrary constants are there. That's why order of the differential equation is 2. Check. So differentiate this one, 1 by a plus 1 by b into y1 is equals to 0. Again we have to differentiate 1 by b into y1 differentiation is y2 is equal to 0. This becomes y2 is equals to 0. Number of arbitrary constants in the given curve equation is 2, and we got the order of the differential equation is also 2. That is the way of finding, that is the way of forming the differential equation for the family of straight lines. Here this is the meaning. What is family, sir? Family means this is a straight line, x by a plus y by b is equal to 1, because for different values of a and b you will get different lines. All those lines, all those family of lines, differential equation is given by this one. So another question is given like this. So the question is given as y is equals to a into e to the power of 3x plus b into e to the power of minus 2x. So that is the given curve equation. We have to find the differential equation for this family of curves. Can anyone say for this family of curves differential equation, what is the order? Order is equals to 2, because number of arbitrary constants is equals to 2. Observe here. So y1 we are finding, y1 is equals to a into e to the power of 3x into 3 plus b into e to the power of minus 2x into minus 2. That is the first differentiation. What I am doing, observe here, y1 is equals to 3 into a into e to the power of 3x plus 3 into b into e to the power of minus 2x minus 5 into b into e to the power of minus 2x. I hope so everyone follow this one. Here minus 2 times is there, that I written as 3 minus 5, minus 2 times only. Now we can write this one as y1 is equals to, we can write this one as 3 times y, that's why 3y minus 5 into b into e to the power of minus 2x. Again we can write this one as y1 minus 3y is equals to minus 5 into b into e to the power of minus 2x. Again differentiate this one. y1 differentiation is y2 minus 3 times y1 is equals to minus 5 into b into e to the power of minus 2x into minus 2. Now tell me, in place of minus 5 into b into e to the power of minus 2x, what we can write? We can write y1 minus 3y. So we will get y2 minus 3 times y1 is equal to minus 2 into y1 minus 3y. What about the simplification? That simplification you will get y2 minus y1 minus 6y is equal to 0. So for this family of curves, this is the differential equation. So this is the way we have to do that particular question for the board exam. The same question I am doing in another way. All of you observe here. What we got? Y is equals to a into e power 3x plus b into e to the power of minus 2x, that is y. Again differentiate this one. y1 is equals to a into e power 3x into 3 plus b into e power minus 2x into minus 2. That is first differentiation. Come on, do the differentiation again. y2 is equals to a into e to the power of 3x into 9. 3x differentiation, 3 again, 9 minus or plus b into e to the power of minus 2x into minus 2 into minus 2, it becomes 4. Now observe here. So we can write this one as y, next we are writing y1, next we are writing y2. a into e power 3x coefficient is 1, b into e power minus 2x coefficient is 1. Next, here in y1, what is a into e power 3x coefficient? 1. Here b into 3, not 1. 3 and b into e power minus 2x coefficient is minus 2. Next, here y2, a into e power 3x coefficient is 9. Here b into e power minus 2x coefficient is 4. This determinant is equal to 0. Now find out the value of this determinant. This determinant value definitely will get y2 minus y1 minus 6y is equal to 0. So the another way we can do this question as, we can write, but actually we will discuss in this one in engineering mathematics or when we are doing BSc, degree BSc, you can also discuss this idea, but at present try to remember this one. Auxiliary equation is, the auxiliary equation is d minus 3 into d plus 2 is equals to 0. That means an auxiliary equation whose roots are 3 comma minus 2. So that's why we can write this one as d square minus d into 3 plus minus 2, this multiplication, minus 6 is equal to 0. That's what we can write. Second derivative of y minus y1, the first derivative, because this simplification is 1, that's why minus y1 minus 6 into y is equal to 0. So directly we can write the answer like this. So this is one method we can do like this for the board exam. This is another way we can do it easily, and this is directly we can do for objective exams. The roots 3 comma minus 2 are the roots for which equation? 3 comma minus 2 are the roots for the equation d square minus 3 plus minus 2 into d plus 3 into minus 2 is equal to 0. That's what directly we got. y2 minus y1 minus 6y is equal to 0. That is the differential equation for this family of curves. This family of curves involves two arbitrary constants. That's why order of the differential equation is also 2. Order is 2. Number of arbitrary constant in the solution also 2. This solution is called a general solution for the given differential equation. So observe here what we discussed. Here our discussion is, this is the way we did. Y is equals to a into e to the power of alpha x plus b into e to the power of beta x. Then we can write directly the differential equation as y2 minus sum of the roots into y1 plus product of the roots is multiplied with y is equal to 0. Suppose the equation is there in this form, y is equal to a into e power alpha x plus b into e to the power of beta x is there. Then what we can write? We can write this one as y3 minus sum of the product, sum of the roots is multiplied with y2 in case of 3 roots, alpha, beta, gamma, plus alpha, beta plus beta, gamma plus gamma alpha is multiplied with y1 minus alpha beta gamma is multiplied with y is equal to 0. So when a into e power alpha x plus b into e power beta x plus c into e power gamma x is there, when it is there in this form, we can write the differential equation as y3. You know what is y3? y3 means third time differentiation, d cube y by dx cube. Like that we can do the questions here. Suppose we have another question here. So the question is given in this way: y is equals to e to the power of 2x into a plus bx. Right? So how to proceed this question? So first of all, the first method, y1 is equals to e to the power of 2x into a plus bx differentiation is b. Next, uv rule I am applying. A plus bx into e to the power of 2x differentiation is e power 2x into 2. Now what we can write this one as y. That's why you will get y1 minus 2y is equals to b into e to the power of 2x. Right? Again differentiate this one. y2 minus 2 times y1 is equals to b into e to the power of 2x into, come on, into 2. Now in place of b into e power 2x, what we can write? y1 minus 2y. Therefore we will get y2 minus 2 times y1 is equals to 2 into, in place of b into e power 2x, we can write y1 minus 2y. Now this complete simplification, what we will get? So in place of b into e power 2x, now the simplification is y2, yes, minus 2y1, this becomes minus 4y1 plus 4y is equals to 0. It is same meaning. Here it is, we can write this one as y is equal to a into e power 2x plus bx into e power 2x. Now what happens? Repeated roots. Are 2 comma 2 are the roots. That's why we can write directly d minus 2 whole square is equal to 0. That's why we can write d square minus 4d plus 4 is equal to 0. D square second derivative y2 minus 4 into y1 plus 4y is equal to 0. Check. We got the same answer, right? So one more question we will discuss. The question now it is given in this way. So the question is given as y is equals to ax plus b divided by e to the power of 3x. Come on, how to proceed? Can you tell me for objective exam how to do this question? Because its meaning is what? Y is equals to ax plus b into e to the power of minus 3x. So what we can write this one? D plus 3 whole square repeated root. 3 minus 3 is a repeated root, right? So that's why we are getting d square plus 6d plus 9 is equal to 0, which we can write it as y2 plus 6 times y1 plus 9 times y is equal to 0. So that is the differential equation for this family of curves. This family of curves involves two arbitrary constants. That's why order of the differential equation is 2. For this differential equation, this is the general solution because order of the differential equation is equal to number of arbitrary constants. Okay, next another question. The question now it is given y is equal to ax plus b into e to the power of 3x plus c into e to the power of 5x. Come on. Nothing, because it is a different root. Here repeated root. So what we can write? That we can write it as d minus 5 into d minus 3 whole square is equals to 0. In place of d cube, third differentiation. In place of d square, second differentiation. In place of d, first differentiation. Constant is multiplied with y. So you will get the differential equation for that family of curves. Okay. So here repeated root 3 and here another root 5. That's the reason I written d minus 5 into d minus 3 whole square. Let's have another question. So otherwise if you want to write, you go 3, 3, 5. How to write? This can be written as y3 minus sum of the roots. 3 plus 5 is multiplied with y2. Next, sum of the product of the roots taken 2 at a time. First one is 3 into 3, next one is 3 into 5, next one is 3 into 5 is multiplied with y1. Final one is minus 3 into 5 is multiplied with y is equal to 0. 3 3s are 9, 9 5s are 45. This simplification also you will get an equation like this. This is equal to y3 minus 11 into y2. Here 39 into y1 minus 45 into y is equal to 0. No doubt, you can simplify this one. You will get this equation as d cube minus 11 into d square plus 39 into d minus 45 is equal to 0 you will get. That's why you will get the same equation. Okay. So like that we can do that particular question. Let's see, another question is given like this. Y is equals to e to the power of x into a cos x plus b sin x. That is a given equation. Y is equal to e power x into a cos x plus b sin x. For this family of curves, we have to find out the differential equation. Okay. y1 is equals to e to the power of x into, we have to apply UV rule, minus a into sin x plus b into cos x plus a cos x plus b sin x is multiplied with e power x. Differentiation is e power x. Now what we can write this one as y, shift to this side. So you will get y1 minus y is equals to e to the power of x into minus a sin x plus b cos x. Again differentiate this one. y1 differentiation is y2 minus y1 is equals to e to the power of x into its differentiation minus a cos x minus b sin x plus minus a sin x plus b cos x. Again I am applying UV rule. Into e power x differentiation is e power x. Now if you take minus common, it is y or not, and this is nothing but the given y1 minus y. So we can write this one as y2 minus y1 is equals to, this we can write minus y, and this we can write it as y1 minus y. Yes, so we are getting y2 minus 2 times y1 plus 2y is equals to 0. So that is the answer we got. But how to do this one? This one we can write it as, it has roots. The roots are d is equals to 1 plus or minus 1 into I e power alpha x into a cos beta x plus b sin beta x. Observe here, e to the power of alpha x into a into cos beta x plus b into sin beta x. Alpha and beta are fixed constants, a comma b are arbitrary constants. Then we can write d is equals to alpha plus or minus I beta. That we can write it as d minus alpha whole square plus beta square is equals to 0. Because alpha shifted to this side, squaring on both sides, I square beta square, I square is equal to minus 1, that's why we got d minus alpha whole square plus beta square is equal to 0. This is the auxiliary equation we got. Now we can find out the differential equation, right? Now the same, we got d is equal to 1 plus or minus I we got, that's why we can write that one as d minus 1 whole square plus 1 is equal to 0. This further we can write it as a d square minus 2d plus 2 is equal to 0. So we can write this one as y2 minus 2 times y1 plus 2y is equal to 0. So this is the differential equation for this family of curves. So for objective exam we can do in this way. This is the procedure we have to follow for the board exams. Let's have another question discussion of this type. Now the question is given in this way, y is equals to e to the power of 2x into a into sin 5x. That's what I am saying. Alpha and beta are fixed constants. Here 2 comma 5 are fixed constants. Plus b into cos 5x. So a comma b are arbitrary constant. Directly what we can write this one as? This we can write it as d minus 2 whole square plus 5 square is equal to 0. That's what we can write, d square minus 4d plus 29 is equal to 0. That's why for this family of curves, the differential equation is given by y2 minus 4 times y1 plus 29 into y is equal to 0. Now another question is given like this. The question is given now, y is equal to a into sin x plus b into cos x. So I can write this question as e power 0x into a cos a sin x plus b cos x. We can do in the same way or not? Come on, how to write? This we can write it as d minus 0 whole square plus 1 square is equal to 0. That's why we are getting d square plus 1 is equal to 0, which is nothing but y2 plus y is equal to 0 is the differential equation for this family of curves. Next question is given in this way. The question is given y is equals to e to the power of 2x into cos 7x. Hey Ram. E to the power of 2x into cos 7x. What we can write this one as? This can be written as e to the power of 2x into a cos 7x. Okay, so this we can e power 2x into a cos 7x. What we can write this one as? A into cos 7x plus b into sin 7x we can write or not? Okay, so for this family of curves we can write the differential equation as d minus 2 whole square, d minus 2 whole square plus, right, d minus 2 whole square plus 7 square is equal to 0. Now you will get d square minus 4d plus here 49 plus 4 you will get 53 is equal to 0. That is nothing but y2 minus 4 times y1 plus 53 into y is equal to 0. That is the differential equation for this family of curves. So this is another question here. The question is given as y is equals to a into e to the power of 2x plus e to the power of 3x into b sin x plus c cos x. Right? So now how to do this one? It's a different factor and this one you know how to do. So that's why we are getting d minus 2 into here. This we can write it as d minus 3 whole square plus 1 is equal to 0. Now this simplification you will get a cubic equation. You can write. So another question is given here in this way. Y is equals to c1 into e to the power of x plus c2 plus c3 into e to the power of x. So immediately after seeing what you will think, sir, C1, C2, C3, three arbitrary constants are there. That's why we have to differentiate it 3 times. We have to differentiate it 3 times. So that means third order differential equation you will get. No, check. Because these constants we can write in this way. C1 into e to the power of x into e to the power of C2 plus C3 into e to the power of x. Now if you take e to the power of x common, if you take e power x common, you will get c1 into e power c2 plus c3. Now this total is a single constant or not? Y is equal to a into e power x. So that a can be eliminated with only one time differentiation. That's why you will get the differential equation of order 1. So we can write that one as y1 is equals to a into e power x. Right? So in place of e power a into e power x we can write y. So y1 is equals to y only. So c1, c2, c3, so many constants are there, but all those constants are equal to a single constant. Right? Next he is asking, form the differential equation for the family of circles touching y-axis at origin. Observe here. This is the family of circles. In a circle touching y-axis at origin. This is also a circle touching y-axis at origin. Family of circles touching y-axis at origin. Family of circles touching y-axis at origin. Or a family of circles touching y-axis at origin. Here also touching y-axis at origin. Touching y-axis at origin, yes or no? So for this family of curves, we have to find out the differential equation. Observe here, a circle touching y-axis at origin. Circle touching y-axis at origin. Center must be on x-axis. If you are taking center as a comma 0, then radius is also a. That's why for all these family of circles with the center a comma 0, radius is equals to a. For different values of a, you will get different circles. So for this family of circles, we have to find out the differential equation. Now what I am doing, observe here, x minus a whole square plus y minus 0 whole square is equal to a square. So this is the family of circles. Now we are simplifying this one, x square plus a square minus 2ax plus y square is equal to a square. A square cancel. We are getting x square plus y square is equals to 2ax. Now differentiate this one. 2x plus 2y into y dash or y1 is equals to 2a. Right? Now this is 2x plus 2y into y1. In place of 2a, what we can write? X square plus y square divided by x. So from this equation and this equation. Here this is the curve after simplification we got this one, and this is after differentiation. From these two we eliminated A. What is our target? We have to check how many arbitrary constants are there. Only one arbitrary constant is there. One time only we have to differentiate. We did the differentiation one time, and in the final answer there is no involvement of arbitrary constant. So we can write this one as 2 into x square plus 2x y1 is equal to x square plus y square. Shift all the terms to that side, you will get x square, right, minus y square plus 2xy into y1 is equal to 0. This is the differential equation for the family of circles touching y-axis at origin. Next he is asking, find the differential equation of family of ellipses. Find the differential equation for the family of ellipses. Find the differential equation for the family of ellipses whose focus set y-axis, center at origin. Observe here. So this is an ellipse, focus is on y-axis, center at origin. This is an ellipse, focus on y-axis, center at origin. This is an ellipse, focus is on y-axis, center at origin. This is an ellipse, focus is on y-axis, center at origin. This is an ellipse, focus is on y-axis, center is at origin. For this family of ellipses, we have to find the differential equation. Observe here, x square divided by a square plus y square divided by b square is equals to 1, where a is less than b. That we have to write. Okay. So for this family of ellipses, I am going to find out the differential equation. Now how many arbitrary constants are there? 2 constants are there. We have to differentiate it 2 times. Come on, first time 2x divided by a square plus 2y divided by b square is equal to 0. Therefore we are getting y by b square is equals to 2y into y1. Y square differentiation is 2y into y1. So that's why y1 by b square is equal to minus 1 by a square. Right? Next we can write this one as something minus x by a square. Okay, very good. y1 divided by x is equal to minus b square divided by a square. Now again we have to differentiate this one. Again differentiate. We have to apply u by v rule. X into its differentiation uv rule. Y into y1 differentiation is y2 plus y1 into y differentiation is y1 minus y1 into x differentiation is 1 whole divided by x square is equal to constant. So that is the way of doing this particular question. Okay, so you can observe here 2 arbitrary constants are there, 2 times differentiation I need. In the final answer there is no involvement of arbitrary constant. That is the way of formation of a differential equation for the family of curves. Once again check, what is the order of the differential equation? If the order of the differential equation is 2, then in the general solution of the differential equation, number of arbitrary constants is 2. Number of arbitrary constants is equals to 2. But what about the number of arbitrary constants in the particular solution? In the particular solution, number of arbitrary constants is always equal to 0. So that is about the discussion regarding formation of a differential equation. Next class I am going to discuss about solution of the differential equation. Okay, bye bye.